Welcome back. This is lesson 13.3. Mean absolute deviation. For short, we call it MAD. It might drive you mad. But it's not too bad. Okay? So I will be able to calculate the mean absolute deviation for any data set. I will also understand how the mean absolute deviation, but let's just put MAD for now, represents how spread out the data is. Okay, vocabulary for this lesson. Variability is how spread out data is. The mean is the mathematical average, which we find by adding them all together and dividing by how many there are. Mean absolute deviation we're going to add to our vocabulary page. So pull that out. Alright, the mean absolute deviation, for short, MAD, is the average distance of all the data points from the mean. So remember how we use the mean as center? Well, you're trying to figure out how far every number is from the mean, and then you're going to find that average distance. So let's look at what we have here. We have points scored at a gymnastics meet. We have Mary and we have Ella. So we have Sarah and Ella are competing for the one slot to compete at the state competition for their school. Which girl should the coach pick? Why? Let's explore using the mean absolute deviation. So we have each girl's score at each meet. So we're first going to calculate the mean of each girl's scores. So the mean. So Sarah scored 5. Oh. Why do we have Sarah? Okay, that's Mary apparently. I don't know why. Typo. So let's fix that. This is Mary. And this should be Mary also. Sorry about that typo. So we have Mary, who scored 5 points. In the second meet, she scored 8 points. In the third, she scored 9 points. Fourth meet, she scored 10 points. Fifth meet, she scored 3 points. Maybe she hurt her foot or something. And then she scored 7 points. Okay, let's add that up and then divide by 1, 2, 3, 4, 5, 6 meets. So we have 5 plus 8 plus 9 plus 10 plus 3 plus 7. So there's all our scores added up. Divide by 6 and we get an average score of 7. So the mean score was 7. So let's make a graph here for Mary. 7, about right here. Alright, let's look at Ella. We have her first score was 7 points, plus her second score was 6 points. Her third score was 7 points. Her fourth score was 8 points. Fifth score was 6 points. And her last score was 8 points. And we're going to divide that by 6. So we got 7 plus 6 plus 7 plus 8 plus 6 plus 8. And that gives us a total of 42 divided by 6. So both of their averages are the same. So usually a coach would look at the means and take the higher average. But in this case, we have two girls who have the exact same average. We just need to determine which person we should take, because they can only take one. So what we're going to do is we're going to see who's more consistent. So we have, I know it said Sarah's, but Mary. Maybe I should just change this to Sarah up here, but whatever. So Mary's scores. Mary's scores, we had 5, 8, 9, 10, 3, and 7. So to calculate the mean absolute deviation for Mary, we're going to find her distance from the mean. So how far is from 7? Well, that would be 2 units away. So that's what we're putting here, the distance from the mean. 8 is 1 away from 7. 9 is 2 away from 7. 10 is 3 away from 7. 3 is 4 away from 7. And 7 is 0 away from 7. So that's just how far each number is from the mean. All I did was subtract the bigger number minus the smaller number, whichever it was. So 7 minus 5 gives me 2, or 8 minus 7 gives me 1. Alright, let's look at Ella's scores. She had 7, 6, 7, 8, 6, 8. So we had from her mean of 7, which would be a distance of 0. 6 is 1 away from 7. 7 is 0 away from 7. 8 is 1 unit away from 7. 6 is 1 unit away from 7. And 8 is 1 unit away from 7. Okay. So to find the mean absolute deviation, after we found the distances from the mean, so you have to first find the mean. Then you have to find out how far each number is from the mean. Now we just find the average, or the mean, of the distances. So we're going to add these up, divide by 6. So we have 2 plus 1 plus 2 plus 3 plus 4 plus 0. So all numbers divide by 6. We get 2. So Mary's mean absolute deviation is 2. The average distance from her average is 2. Okay, let's do Ella's. Well, this is easy. 0 plus 1, so that's going to be 1, 2, 3, 4. So 4 divided by 6. We get 0.6666, so I'm going to round it to 0.7. About 0.7. Now what does this mean? The higher your mean absolute deviation, the more spread out the data is. So that means her scores, and we can kind of see that, are more consistent than Mary's. Now Mary was scoring 9s and 10s. We never saw a 9 or 10 out of Ella. However, we've got a 3 here and a 5 here, and Ella never had that either. So she had really low scores and really high scores. Whereas Ella has stuck around the 6, 7, 8 range for all of her meets. So this is where I'm going to make you make the decision. Which athlete should be selected to go to state? Why? Would you want to risk taking her? She could possibly get you a 9 or 10. She might also get you a 3. Ella, on the other hand, is probably going to get you a 6, 7, or an 8 compared to her. She could be anything between here and here. But I want you to tell me which athlete do you think should be selected and why. Alright, let's find the mean absolute deviation for the following sets of data. So, we have this data. I always like to organize it from least to greatest. So, 18 would be the smallest. Then 24. Then 37. And 58. And then 65. Okay. Order from least to greatest. Let's find the mean. Add it up, divide by how many there are. 18 plus 24 plus 37 plus 58 plus 65. All of that divided by 1, 2, 3, 4, 5 numbers. And that gives me 40.4. Okay, remember the mean absolute deviation. We have to find the mean. Then we have to find out how far each number is from the mean. So, always take the highest minus the lowest. So, 40.4 is higher than 18, so I'm going to minus 18 from it. And that gives me a distance of 22.4. Okay, 24. So I'm going to do 40.4 minus 24. That gives me 16.4. 37 is still lower, so 40.4 subtract 37. This number is 3.4 away from the mean. 58 is larger than 40.4, so I'm going to put it first. So 58 minus 40.4. That gives me 17.6. And 65 minus 40.4. That gives me 24.6. Okay, we have all the distances from the mean. Now we're going to add these up and find the average distance. So the mean distance. So 22.4 plus 16.4 plus 3.4 plus 17.6 plus 24.6 equals. So we added that up, got 84.4. We're going to divide that by 5 because there are 5 numbers. So the average distance from the mean is 16.88 units. Alright, let's see about this one. We have 4 numbers. So we got to organize them first. So I'm going to put 389 first. 413. 416. And 434. We only have 4 numbers, so we'll add those up, divide by 4. So 389 plus 413 plus 416 plus 434. We get that, and we're going to divide it by 4 because there's 4 numbers here. So the average is 413. Alright, figure out the distance from the mean. 389, so 413, subtract 389, that's an average distance, or that's a distance of 24. 413 minus 413 is 0. 416 minus 413, that's only 3 away. 434, subtract 416 equals 18. Alright, we have our distances from the mean. Now to find the mean absolute deviation, we find the mean of the distances. So, 24 plus 0 plus 3 plus 18 gives us a total of 45. And now I've got to divide that by 4 because there are 4 numbers. So the average here would be 11.25. So which data set is more variable? Explain. So which one is more spread out? Based on this, doesn't matter that these numbers are big or small, we're only interested in this. 16.88 is larger than 11.25. So the first data set has more variability because the mean absolute deviation, or average distance from the mean, how far each number is from the center, is larger than the MAD of the second set. Alright, rate yourself on this concept. How do you feel about finding the mean absolute deviation? 0, 1, 2, 3, or 4? Take pictures and turn it in on Google Classroom.